All right, hello everyone, this is Mr. Crozier, and I wanted to help you with problem 5 from our in-class assignment today. It says a plane leaves on an airport on a bearing of 280 degrees for 150 kilometers. How many kilometers north of the airport is the plane? So the key to these problems is to draw a neat picture. And right here I have my compass rose, north, east, southwest, and I have the degrees in here. This is a 0 bearing, 90, 180, 270. It's just like the unit circle, except it's not starting on the axis over here, and it's not going counterclockwise, it's going clockwise. But the math is the same. The numbers just line up differently. So first off, let's draw where the plane's going. 280 degrees. Well, here's 270, and we go 10 degrees past this. So try and get something to scale. Maybe that's a good drawing right there. This is 280 degrees. Definitely not in the middle between these two. It's definitely closer to 270. So there's where the plane goes, and the plane travels for 150 kilometers. Well, we don't have numbers on here, so we can put that wherever we want. I'm going to put it way out here, and that's where the plane is. And this mark right here, this side is 150 kilometers. That's the distance from the airport, which would be right here, and the plane, which would be right there. And the question we're asked is, how far north is it? Well, north is straight up. So if I draw a line straight across right here, well, that's a right angle. And this distance right here is how far north he's traveled. So you can see we have a right triangle, kind of like the unit circle, except obviously we're counting different ways, and our triangles don't have to be on this x-axis. So the question is, what can we do with this triangle? Well, let me sketch it over here. Maybe you might see it better if we put it up and down. It's still this long triangle here, and I just rotated it this way, and x is down at the bottom now, and this is 150. So maybe you can see it better if I have this triangle here. And let's name this angle right here theta. That would be that one right there, wouldn't it? All right, so what is theta? Well, all we know is that from here, this 0 line, all the way around to here is 280 degrees. Well, I want to know what this angle is here in theta. Well, if I'm at 280, and if I add on 80 more, I'll get to 360. So this angle right here is 80 degrees. And everything's to scale, and it kind of looks like an 80-degree angle. The orange is 280, 80 more makes back to 360. So now all we have to do is look at this triangle and see what kind of ratio can we write. Well, if this is theta, we have, what do we have here? We have an adjacent side, an opposite side, and a hypotenuse. Same thing over here, adjacent, hypotenuse, opposite. And it looks like a cosine ratio to me. The cosine of 80 degrees, this is our angle, and we're going to put it into a side, and the sides of it are x over 150. Solve for x. X is equal to, if you cross multiply those, you'd have 150 times cosine of 80. That is an exact answer, but we're asked to find an approximate answer, so we're going to take 150, make sure your calculator's in degrees, 150 times the cosine of 80 degrees, 26.0. And what are the units? We've been asked to find distance, 26.0 kilometers. Key to this problem, draw a neat picture, figure out the angle theta. If you need to redraw your triangle in a way that makes a little bit more sense to you, redraw the triangle. You don't have to, though. You could have still seen that this is theta, cosine is adjacent over opposite. Sometimes it's a little bit easier if you draw this picture out to the right. Then set up your triangle, solve it. We're taking this 80 degrees and turning it into the sides over there. Then you can work backwards, figure out your x. All right, hope this helps.